What if it's too hard?
I'm gonna push you.
What if it's too long?
I'm gonna push you.
What if it's too tough?
I'm gonna push you.
What if you're just too young?
That's not true.
What if you're not good enough?
That's not true.
Why? Because
I can do anything I put my mind to.
I believe in you.
Chin up
Believe in yourself.
and high.
Tell me why.
We push through anything we put our mind to.
Let me go to disjoint set. Let me go to disjoint set. So disjoint set, it says two sets are said to be disjoint when they have no members in common. The intersection of disjoint sets or disjoint sets, yes, is therefore an empty set. Let me read it again. Two sets are said to be disjoint when they have no member in common. No member in common at all. The intersection of disjoint sets is therefore an empty set. All right, let us look at an example quickly. Clean my board. All right, so let me work with this part of the board. Working with this part of the board now. All right, good. So for example, call my set J. So set J equal and set K equal. All right. So in set J, the elements are cool, I should say. Cool, hot, cold, cold, and of course warm. In set K, I have fog, I have flood, I have drought, and I have storm. So in set J, we have cool, hot, cold, warm. In set K, fog, flood, drought, storm. Now we want to know the disjoint set here. Do an example of a disjoint set here. Now we say that the intersection, it don't have anything, right? A disjoint set, the intersection have nothing in there. All right, nothing. So what is in, so in set J, we have cool, we don't have cool in set K. Hot, we don't have hot in set K. Cold, we don't have cold in set K. Warm, we don't have warm in set K. All right, so we don't have nothing in common there. So nothing forms the intersection. So therefore it is an empty set, because the definition says that two sets are said to be disjoint when they have no member in common, and you see that they have no member in common there. Set J and K don't have nothing in common, and the intersection of disjoint set is therefore an empty set. All right, the intersection. So there is nothing in. See the intersection, nothing in common. All right. So nothing that is in J is in K. Nothing is in K, is in J. Alright? So it's an empty set there. So for example, I write it like this: J intersect K is equal to an empty set. Or I can write it like this: see that? Good. So J equal cool, hot, cold, warm. K equal F, flood, drought, storm. Sorry, fog, flood, drought, storm. And you see that the intersection have nothing in common. Nothing that is in this set is in this set. Nothing is in J, sorry, is in K, and nothing is in K in J. So therefore the intersection is empty, and the elements, yes, two sets are said to be disjoint when they have no member in common. So the elements, there are no elements in common, or no members in common. All right, bear that in mind. All right, so we're moving right along. Getting there, we're getting there, we're getting there. So we want to look at first subset. We'll look at subset next. So we're going to look at subset next. Before we get to Venn diagram, we're going to look at subset. All right, subsets. Now, we say that, am I still recording? Yes. So subsets. Set A is said to be subset of set B if some elements of set A is also elements of set B. Let me say that again. Set A is said to be subset of set B if some elements of set A is also elements of set B. So let us do an example of this one. All right. Erase my board. All right. So we are enjoying class so far. I believe so. Yes. Learning takes time, students, and you need to watch out all the video presentation, all the video presentation that I'm doing right now. Might be long, but you need to watch it. Why? Learning takes time, and I promise that if you watch it out, if you watch out all this video, all of these contents that I'm going through, you will have a good clear understanding of sets. All right, and that's the aim, because if learning don't take place, then teaching don't take place. All right, learning have to take place for teaching to take place. So I hope you have learned something so far. All right, so let us continue on subsets. All right, so I'm going to do an example of subsets. So let me read the definition again, so you have a good clear-cut understanding, or a good clear-cut understanding of what I'm saying for subsets. All right, so set A is said to be a subset of set B if some elements of set A is also elements of set B. All right, so for example, I would call this set A, and 1, these are the elements in my set A. So set A equal 1 and 2. Now set B is equal to 1, 2, 3, 4. All right. All right. So you tell me now, is A a subset of set B? Is A a subset of set B based on the definition that you have read? Set A is set A, a subset of set B. If you want to look back on the definition, here you go. Set A is said to be subset of B if some elements of set A is also in set B. So we see that uh, some elements that are in A are also in B here, don't it? See that elements that are in A also in B. See that elements in B also in A. So some of the elements that are in B is in A. See that? Some of the elements that are in A are in B. So therefore we can say that the subset, or we can say that set A is a subset of set B. We can say that set A is a subset of set B because A contains some elements that are in set B. Alright, so we can say that A is a subset of set B. Now we can write it like this. A is a subset. Please remember this is the subset symbol. A is a subset of B. Alright, A is a subset of B. Beautiful. Let us move along. So we're going to look at the last one, which contains a lot. This is Venn diagram, a Venn diagram. Alright, so a Venn diagram can be used to show the intersection and union of sets. A Venn diagram can be used to show the intersection and union of sets. When drawing a Venn diagram, we use a rectangle to represent the universal set and circles inside the rectangle to represent its subset. So you see why we do the subset first. Alright, good. So let us go into this. I think I need I'm going to change my board quickly. I'm going to do an example of this, the Venn diagram. So I will call this set A, set A, and I say set A is equal to 5, 6, 7, 8, 9. Alright, and we have set B equal to 2, 4, 6, 8, 10. Alright, good. So we have set A and we have set B. Alright, set A is equal to 5, 6, 7, 8, 9. Those are the elements in set A. Set B, the elements in set B are 2, 4, 6, 8, 10. Alright, beautiful. So it says a Venn diagram can be used to show the intersection and union of sets. Alright. When drawing a Venn diagram, we use a rectangle to represent the universal set and circles inside the rectangle to represent its subset. Now, we first want to represent a Venn diagram using set A. So a Venn diagram is just simple, just a simple circle like this with the members that in set A. Alright, members in set A. So we have 5, we have 6, we have 8, we have 7, and we have 9. So this is a Venn diagram you're looking at right here. This is a Venn diagram right here. Alright, now the Venn diagram for set B We have 2 circle not drawn to scale class. Don't worry about my circles, worry about the content, please. 6, and I have 8, and I have 10. Alright, good. So that's my Venn diagram. That's uh, the set A. This is set A Venn diagram. This is set B Venn diagram. Alright, good. Now I just want to show you a representation of the Venn diagram. Alright, so these two right here are Venn diagrams, and set A is represented in the Venn diagram, and set B is represented in this Venn diagram right here. Alright, so it says now a Venn diagram can be used to show the intersection and union of sets. Alright, the intersection and union of sets. Let us represent the intersection and union of sets right now using the Venn diagram. Alright, so I draw back my circles. Remember the intersection and union of sets, we want to represent it using the Venn diagram. Alright, Venn diagram can show it, right? Good. So here are my two Venn diagrams, and I want to show the intersection, so they overlapped each other. I should point this out that intersection of sets is the same thing as overlapping sets. Alright, intersection of sets is the same thing as overlapping sets because they overlap. In truth and in fact, they overlapped each other. Yes, so they call overlapping set as well. So if you see the word overlapping sets and intersection sets, same thing. All right. So just want to clear that up. So we want to find the intersection of the sets now. The intersection of sets now, using both the Venn diagrams. All right. So look at both sets now. Set A, set B. All right. So I call this set A, and I call this set B. All right. Set A, and this is set B. All right. Now look at the both sets, and we're going to find the intersection. Remember that intersection are the one that have both things in common. So both sets supposed to have you should find the commonality between both sets. All right. In other words, find the commonality between both sets. All right. So what are common in this set, or what is in this set that is also in this set? So we see 6. All right. So 6. Let me cross out 6. So 6 can come right here. What else is common? What else is common? All right, 8. We see that 8 is in set A and 8 is also in set B. So these two numbers are the intersection, all right, of A and B. All right. So we want to write the subsets now, the subsets, because the universal set is all the numbers that are available. All right. So all the numbers that are available in this set now. So 5, 6, 8, 7, 9, 2, 4, 10. All right. All right. So this is the universal set. So this is a universal set. Pay attention, class, to the universal set. All right. Pay attention to the universal set. So this is the universal set. All right. All right. So we want to write now the subsets now of the universal set. So in set A, we already put 6 and 8, so it's just 5, 7, and 9, because 8 and 6 is common to both sets. All right, so we don't have to put it back over here. All right, good. So over here now, leave out 8 and 6 in this one and put 2, 4, and 10. All right, good. Subset, those are subsets now of the universal sets. All right. All right. All of these numbers rather are the subsets of the universal set, because these numbers can also, that are in A and B, can be found in the universal set. So they are subsets of the universal set. All right. So we represent this now. We represent the universal set now as according to the definition. My recording. Praise Jesus. All right. So we represent the universal set now. So it says when drawing a Venn diagram, we use a rectangle. Oh, we didn't do one thing. We didn't find the union of sets. All right. So we're gonna find the union of sets first. All right. So the union of set for A and B now would be A union B. A union B would be all the numbers that are in A and B without repeating them. All the numbers that are in A and B without repeating them. That is the union of sets there. So let us write it. So we have 2, we have 4, yes, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10. Right? Beautiful. So these are all numbers that are in A and B without it being repeated. This is the union of sets. All right? Union of sets. Right here. Now we want to look at the next part of the definition. It says when drawing a Venn diagram, we use a rectangle to represent the universal set now, and circles inside the rectangle to represent its subset. While we represent the subset, going to represent our universal set. Let me go back one more time to the definition. So it says a Venn diagram can be used to show the intersection and union of sets. We just represent that. Now it says when drawing a Venn diagram, we use a rectangle to represent the universal set. So we're going to use a rectangle now to represent a universal set, and circles inside the rectangle to represent its subset. We already drawn the circles, and we already show the subset of the universal set. All right. So we're going to draw the rectangle now to represent our universal set. All right. So here's our rectangle to represent our universal. All right. So here's our rectangle. Draw a better one. I think I can draw a better one, man. One is too crappy. So here's my rectangle to represent my universal set. All right. Good. And always put a U in the upper left corner. In the upper left corner of the diagram, put a U to represent the universal set. All right. So this is my universal set. These are my subset. The numbers here are the subset of my universal set. And the circles are my Venn diagram, and we show the intersection. All right. And we show the union between both sets. All right. Without repeating the elements. So write back all the members or the elements that in set A and set B without repeating the elements or members. So that's the union set there. All right, and this is the universal set right here that we have represented. All right, so anything else we have to work out? Let me look. I think that's it. All right, that's it. So hope you have learned something, and I hope that you will practice until you become perfect on this topic sets. All right, so I will be giving a test on this topic, so I want you to pay attention to the contents and ensure that you watch it more than one time to achieve 100% in your test. All right, get a good understanding. Scripture says in all you're getting, get a good understanding. All right. So God bless you. God keep you. Stay tuned for the next teaching and learning exercise.